Okay, I think we can start. It's 2 minutes after the convenient time of 20 minutes after the hour. So let's start. This is my Call the Doctor session, my Tuesday of the month. And first and foremost, any questions from the HDF community that attends this recording? If not, or yes. Robert, are you saying something? You're muted.
No, I'm ready, Alexander.
Okay, no worries. Then sorry about the muted mic. I didn't want to force you to unmute. Okay, so main act. I recently, a couple of weeks ago, was contacted by a colleague and friend from England who was working with one of the groups that produce climate simulations for this United Nations Intergovernmental Climate Panel. And they are preparing to have, I think, the 7th generation of these climate simulations. I think it's called CMIP 7. And there was one group that contacted him, mostly through, as far as I understand, more like acquaintances, and said that they heard about cloud optimized HDF5, or they would like to have cloud optimized HDF5 files they produce, but what is that and how to go about it? And so, and also they said, well, we have these previous simulations from the CMIP 6 generation of climate, what to do with them? Like they are now served from wherever they are served. And they would like to have them also climate optimized. And so he contacted me and said, look, I mean, we have these they're NetCDF4 files, but as we know, those are HDF5 files in bytes. And so what to do with them? How can we now turn them into cloud optimized files so we can do something more efficient when it comes to access in the cloud? And he looked into H5repack, and that's how he contacted me. So for those who are maybe new to this whole HDF5 thing, H5repack is command line tool. I don't remember when it showed up, but I couldn't, I went back to release notes in 1.8.0 HDF5 library, and H5repack was already been mentioned that there was some enhancement to it. So at least as old as 1.8.0 release H5repack, so way back when in the history of HDF5, and it can do a lot of things. It's meant to be a command line tool that allows certain modifications of an HDF5 file. And here is the current version of the its help message. I am using the latest development version of HDF5 library and therefore H5repack. So this is as fresh as it gets prior to release, but I don't think that H5repack changed so much its help message. So it allows a lot, and I'm not going to go through these things. Obviously, it's not the point of today's video. But again, it takes an input file, HDF5 file. It essentially generates some new output based on the command line options, modifies the input file's content, and then writes it out into the output HDF5 file. Things that are. Yes, go ahead.
Are you sharing screen? Because we cannot.
No, I'm not.
Oh, okay.
It's good that you guys are all paying attention to what I'm saying. That was my check to see if you guys are allowed. Okay, allowed. Okay, do you see it now? Excellent.
Yes.
Only that. I forgot to share my screen. So as you can see, the H5repack, here's the version I'm using up there. So here's the H5repack help message, and as I said, input HDF5 file, output HDF5 file, and the rest are command line options, how to modify the input file's content. I'm not going to go through all of them. As far as the value for cloud optimizing HDF5 files already existing, there are a couple of options. I'm just going to briefly mention them. One is dash capital S, which turns on a specific file space management strategy that is of interest for cloud optimized files. Complementary to that, there is the dash capital G option that says what is the file's page size going to be of that newly file. That's also something you have to specify. And then, where is another one? Maybe I passed it. There is another one. Is it dash M somehow? Ah, yes, here. Dash capital M or metadata block size, if you like verbose options. This is another strategy or option when you are cloud optimizing files. And this one sets the metadata block size in bytes. And again, I'm not going to talk about why that and whatnot. It means I had at least one video some time ago where I described all these strategies. So I don't know if we're going to have a link to that video, like here up here when I'm talking now, but maybe post editing we'll be able to do it. But yeah, so Google, HDF5 channel, cloud optimized HDF5 files, you should be able to find. So those are the ones that are of interest for cloud optimizing. And another one is also, or generally is changing chunk shapes of HDF5 datasets, or also compressing specific HDF5 datasets. That's all possible, and you use a command line options, and it does. I'm not going to go through how to construct these things again, but I'll mention some that I have used, for example, in this work that I'm going to talk about. So yeah, it can do a lot. And that person, my colleague who was trying to do the cloud optimize his sample netcdf4 files, he tried to use H5repack, and he told me it's kind of working, but it was kind of taking a lot of time. And I said, sure, give me your sample file and I'll take a look and see what goes on. And his file, I don't know where I have this file, but anyway, I'll find it somewhere. It's a netcdf4 file, and specifically, let me see. I think I'll be able to find it. Because it's netcdf4 file, I'm going to use another viewer that sort of suited for netcdf4 files, and I think I have it here. I think that's the one. Maybe yes, maybe no. Oh, no, maybe it's not. No, it's not. So we have to go fishing, but we find it eventually. Where did I put it? How come I don't have it? Sorry for this disruption a little. See, I like this rawness in my presentation. People, it adds to the authenticity of my videos. I'm looking for a file now, which is obviously very interesting, but I'll find it. Open. Wait, is open. Thank you. I think I found it. Downloads, but I didn't. Oh. Ah, there you go. I found it finally. So the file is essentially simple in some ways, but also very interesting in some other ways. So essentially, it's a netcdf4 files with one geo parameter in it that really is the file all about, and this is this one called UAS, and it represents eastward wind. So it's the eastward component of the wind vector, and basically it comprises by data the largest component of the file. Everything else in the file are essentially just coordinates that sort of accompany this main data that describe where in time, latitude and longitude this eastward component of the wind is, and nothing else. So in a way, it's a unique content. Is very simple, with one, as I like to call it, mega variable in netcdf terms, and this is this eastward wind. because it's quite large. You can see there's almost, essentially 292,000 time values and fairly coarse latitude and longitude grid. But what's interesting for the file, first and foremost, it's a typical conventional HDF5 file. In other words, it's not Calv optimized in any way. The other very interesting thing is that all of the variables of HDF5 dataset, now I'm talking about HDF5, so I'll use HDF5 terms. So HDF5 dataset in this file, like time and time bounds that describe time coordinate, are chunked with extremely unacceptable chunk shapes. So for example, time has a chunk shape of 1. So in other words, every value of time dataset is a separate chunk. So basically just the time variable has 292,192 chunks. And the accompanying thing, the time bounds, which is another thing that describes the intervals in time for each time coordinate value, is also chunked extremely frugally with 1/2 chunk shape. So that's one of the problems they try to sort of correct. And accordingly, this mega variable, mega data set that holds the eastward wind component also has a chunk shape of 1/143 by 144. So extremely small chunk, and a lot of them. And so they try to correct all these things with H5repack. So that's about the file itself that people need to know for the purpose of this discussion. I reduce this down here and then I'll show. So I start using H5repack, and I found the H5repack from the development branch, and I also used H5repack from the HDF5 release 1.14.6. And in my case, the way how I built HDF5 library, I used the zilibenG library for the gzip compression, as opposed to the 1.14.6 release, which was the standard zlib. So that also I wanted to see if the zilibenG brings some extra oomph when used to decompress and compress these chunks. So what did I try to do? Here is my H5repack command. Quite sizable, but that's one of the kind of issues with H5repack. There is no more convenient way to tell it what is processing tasks are. So the command line tends to be pretty sausage for fairly even basic stuff work. So here's where I tell it that I want the dataset /time to basically create chunk of this shape, one-dimensional with this many elements in it. So essentially this says create one chunk out of the entire time dataset. And by the way, when you're creating this chunk, I also told it use the gzip compression with the level 4, compression level 4. So that's the way how you in H5repack say, for example, to turn a dataset into a chunk layout and then compress. And then, by the way, I said, when now there's another one, and that's the time bounds. And I, again, wanted to make the entire dataset fit into a single chunk. And then again, I said, well, by the way, also I want that chunk to be compressed. Again, gzip level 4. And finally, I came to this mega giga HDF5 dataset, this eastward wind component, UIS. And I said, now create me chunks that are roughly, as I calculated, about 2 megabytes, maybe bytes in size. And so that came out to be 30 by 143 by 144. So essentially I put 30 original chunks into this one output chunk now. And I said also to apply 2 filters to this HDF5 dataset. First one is the shuffle, and it has to come first when on the command line. And then I also said compress it with gzip and level 4. So this is all the sort of the processing tasks that I specify in the command line. And I wanted to see what the H5repack does. And because we are talking about profiling, there is a very useful command line option called verbose. I'm going to highlight it here. I hope people see it here. I don't know if my font is too small. Let me make it a little bigger so you can see it now. There you go. Verbose equal to. And I wanted to see what H5repack actually does a little bit more and learn how that works. And so H5repack, on getting this verbose equal to option, starts producing some output, diagnostic output. And you can see here that he understood that the time has to be with the chunk, correct chunk size. The time bounds need to have a chunk, chunk shape. Although they're using size, I think we need to bring the vocabulary in line. Chunk shape and chunk size are two different things. And so, confirmed all that my command line options are well understood, correctly understood, and it's going to do things. And now want to say, time gzip filter, time bound gzip filter, and then for UAS dataset shuffle and gzip. So all these things that I said it to do. And then produced all this output here that follows that essentially gives some kind of a timing information about the work that H5repack is doing. So he's now telling me that he's working on the root group, and he's now essentially de facto copying the attributes from the input file into the output file. And he says here that that's an attribute. So you can see here to the left, it says it's an attribute. And now it gives timing read and write. So I know that, for example, for this attribute name, it took almost, just under 1 microsecond to read and write. For the conventions attribute, actually, there was no time to read it, and just a little above 1 microsecond to write it out, and so on and so on. Obviously, that's very useful, but these are tiny amounts of time, so that's not where the time went. So I was looking where the time is going, and obviously I was paying attention to my to the data sets that I said should be modified. And here it is, the first time that it says dataset. Now mentions gzip. I assume this is the compression ratio that it's giving. And now it tells me interesting information, for example, that it took 5.5 seconds to read the elements of the time dataset in the input file, and then gets it out in, this is 0.2 milliseconds. Which is amazing if that's really, I trust H5repack. I'm just commenting on the results. So this means that it essentially compressed 292,192 elements into one chunk, compressed it, wrote it out in 0.2 milliseconds. Excellent. So again, now we are seeing here essentially attributes of this data set being copied, also very fast. Now come to another data set that I told it to do some work. It's time bound, and it now also reports, almost 6 seconds to read. And then this is 0.5 milliseconds, 0.15 milliseconds to actually write it out. Again, very nice. And here comes to the mega giga HDF5 dataset, this eastward wind, that obviously is the biggest time consumer in terms of performance. So it says essentially that it took 166 seconds to read the data from the input file, and then 392 seconds to write it out. And so that's where all the time went in terms of performance.
Alexander,
yes.
does the writing time include new compression? Because you're still applying compression, and you can see that data is not compressible at all, because it's one. It is one. It means it cannot compress it.
Nice that you mentioned that, because when I run H5 dump on the output file, it says it was compression ratio was reported as 1.3 or 1.4.
It's fine, but it's very small compression, and that's why it maybe includes writing with using compression, which really is burning electricity.
Yeah. So again, so this is. But anyway, the output in terms of what H5repack was doing is where it said essentially the time information. I did note that this is a different compression ratio than what H5dump says for this data set. So I don't know why the discrepancy, but yeah, it may not be, that it compresses well, which is kind of an interesting point. Anyway, that's what you can get essentially from H5repack without any effort. You just set the verbose command line option equals 2. This information goes out and all is good. However, I wanted to know, all right, but what exactly is going on inside the H5repack? And for that, you need to now start doing some extra work. And specifically, you need to essentially build both the library and H5repack in a specific way in order to generate profiling information. And I'm working on Mac, and I'm not really familiar with on the Clang instrumentation and all the possibilities to profile applications on my Mac natively. But I knew something about the Linux side of things way when back I was more doing these things, and that tool was gprof. And so and I said, all right, I'm going to do gprof as sort of the first iteration of all this. And because I'm on the Mac and I knew gprof, I basically did this, and I'm not going to talk about that much because that's a lot more information. But anyway, I basically did it by creating a Docker container on my Mac that was ARM64 Linux, and then sort of running gprof and all the other profiling tools in that Docker container, and building the library and all that. And then once obviously when this profiling information was collected, I continued on the Mac to analyze the data. So I'm going to skip that whole process, how to set up Docker container on your Mac and have it connect and all that business. But I'm going to only say how I build the library, because I think that's the and I'm going to use actually an issue that I created because of that in the H5 repository. Again, we're now looking for it. Yeah, there we go. So this is where I'm saying effectively how I built the library and H5repack. And I like these CMake presets a lot. I really find a lot of usage of them. So essentially what it means is that, long story short, HDF5 2.0 will come if you're building from source with this bunch of the CMake presets. And because I'm, always like to borrow from someone who knows more than me, I basically say here that I'm going to inherit a specific presets that are available in HDF5 libraries source code. And because I'm on ARM64 laptop, I'm saying that preset, I'm saying I'm going to use new compilers, I'm going to build everything for the release, and I'm going to enable standard compression filters, which in this case mean gzip and szip. And then on top of that, I'm now starting to say specific things for the selections. I don't want to build documentation. I don't want to build examples. I do want to use zlibng, as I mentioned, for my gzip compression instead of the standard zlib library. I don't want szip because in this case I didn't want to play with that. I'm basically saying don't build me shared libraries, because in this particular case for gprof, everything has to be statically built and linked. And I'm saying I want to enable profiling. And this is what essentially gprof, building for gprof requires. you need to pass this flag -pg when you compile and when you link all of your library artifacts and all of the command line tools. And this one actually was the one that I had to learn a little experiment. If I didn't include this one, which is a standard CMake variable, then H5repack was not generating any gprof output. But if I included it, it was able to generate gprof output. So that's why I created this issue, because essentially this is a standard CMake variable. And maybe in this issue, I'm suggesting maybe we want something specific to HDF5 because it'll allow us to choose where exactly we want this type of information to appear during the build process. But in my case, this worked. So I'm happy that CMake, Excel, linker flags, that was all I needed, and I was golden. And so after that, I ran H5repack with the command line that I just recently explained before. And it took a bit longer, obviously, to run, but I got my gprof output. And what I did with the gprof output later was I used a Python tool called gprof to dot, which essentially can take the gprof textual output, which I generated from the gprof command line, and can create various plots out of this information. And I'll show you the plot that I created. And I got both the dot version, which is the GraphViz dot language. And since this is Visual Studio Code, I can actually have a dot previewer so I can get this information on the right. Or I basically created a SVG output. I forgot what S stands for. V vector graphics, but C simple or scalable, something like that. Anyway, so I can now let me just reduce my and minimize my So this is the output from gprof to dot that essentially tries to kind of visualize what was the profiling information. This is how we plotted it. There is a bunch of this kind of boxes, unconnected ones, but I'm pretty sure, looking at their names, that that's something from the zlib or the gzip compression business. So I said, all right, fine, that's good, but I think this main branch that sort of branches down gives more interesting information. And so you can see there is a split here. Do copy objects, obviously, that I understand. They're copy objects from input to output file. And now we start being split, H5D read, H5D write, and then they kind of follow their separate ways until here where the internal HDF5 library function starts sort of appearing. That they're not part of the public API. And now we see that there is a split. And now both H5D sumwrite and H5D __ read start talking to this even more and more internal HDF5 API functions. And this is sort of the timeline. So I would say that this mem_cb callback, I guess, and all the other thing obviously takes up most of the time, select, iterate, and chunk IO init. So that's basically what I got from this gprof profiling information. Now, because everyone is working on the HDF5 2.0 release, I have not really shown this much and spoke with someone who is much more familiar than me with the internals of the library to see if there is anything, suspicious or something that could say, yeah, this could be improved or something can be improved. But this is where I am right now. This is the data. Obviously, the gprof to dot command line tool allows me to sort of set up the thresholds, how much detailed information I want to include. In other words, I could go all the way to almost 0.001% of time and all the other information here that would make this graph much bigger with many more functions. But I kind of like this output. I think, at least as a first iteration, it tells the story. And as I said, once we make the release 2.0, I'll talk with someone and see if this, indicates something or it is what it is. But so to reel back, why is this interesting? Well, H5repack, as I said, may be, or people are looking at it as a way to cloud optimize their HDF5 files after they were created. Obviously, that's not the right intent. The library, and I think the expectation is you create the files immediately the way you wanted them. But now with all these holdings in HDF5 files and the cloud computing kind of happening relatively recently, there is the need for something that will be very performant to sort of turn these files into their cloud optimized versions. And we'll see if H5repack is the right answer or not. And that's basically what I have. I would stop here. And are there any questions or obviously comments?
Actually, comment. It's clearly it's very good example, and definitely you should talk to Neil. As I read it, it really spends time in when it reads chunk. It reads not bunch of chunks. It reads chunk by chunk, right? Which is already small I/O. And it will be interesting to see, analyzing coordinates of the chunk and the allocation of the file. It is very possible that chunks were written one by one, so they're adjacent to each other. And library can do several optimizations like reading bigger block of file, bringing into memory all those chunks, and then using multi-threading to rearrange data, to uncompress and rearrange data. So there are several optimizations here, and hyperslab selection code is known for it's slow. It needs to be, but at this point, really not much can you do. Also, just yesterday we discussed with John. Of course, big I/O you do, it's better, right? So if we're page I/O will be, but now raw data is not allocated in pages, it's only metadata. Metadata and small raw data, right? The pages. And essentially we should probably think about also, and we will need it for Swimmer, I think, for restoring data, if we want to restore data after crash. To start taking raw data into pages and doing page I/O on raw data, which will help tremendously with the small chunks because they will be in pages. So a lot of optimizations. The question is how we do it. It's a lot of work and some redesigning, but it will be a problem when people start working with more HDF5 data.
Yeah, hopefully someone will look into this video and try to generate his own H5repack profiling and then send to us or something, so we learn more. I only forgot to mention now before. So once the H5repack completed his task and created the output file, so all this effort of creating bigger chunks or chunking some of the HDF5 datasets in the file, the internal metadata went from 41 megabytes to, I think, if I recall, about 570 kilobytes. Just by essentially removing all those thousands and thousands of tiny chunks that some of the HDF5 datasets in this file initially had. Yeah, so that's that. Any more questions? Thanks, Elena.
I would suggest to include, when people try to use small chunks, and sometimes they have to, but at least give them warning or something, and not allow one by one chunk. It just doesn't make sense. A naive user, how will they know? It's really...
Yeah, that's something I was wondering how that came to be. And the only thing I can imagine is that again, it's copy and paste from someone, and people don't really pay attention and don't know all these details and things, and they just go with the flow almost.
Right.
And these things perpetuate. But yeah, so and the reason why this is a problem, I'll tell you, because strictly speaking, if they use the HDF5 library to read this file in the cloud, and it was even cloud optimized without rechunking business, the library would do page read in this file size. So a lot of chunks would be coming with this page.
No, they will not, because chunks are not packed into pages.
Oh yeah, but when you make if you would use H5repack to create the page aggregation version of the file, then chunks go into a file page.
Are they? Are you sure?
Yeah, they do. So for HDF5 library, actually, it's not a bigger problem. Where this really shows up is the other software that doesn't use HDF5 library, like ZAR, or even ZAR. I know for sure. I'm not sure about the H5repack, how that will go, but ZAR definitely, because they go after a chunk, because for them, chunk is what they go after. And so suddenly they have 292,000 chunks to go individually after. Whereas in the HDF5 library case, it would be maybe one page, and that page, file page, and that file page would bring all the chunks, for example, or something like that. So that's also why these tiny chunks is showing up and really making a lot of problems with these other ways. Anyway, that's all I have really. Any more questions or comments?
Alexander, but there is no such thing as H5lint, correct?
H5 what?
H5lint.
There is no H5lint, no.
That would pick up something like these 1 by 1 or one dimension chunks.
Yes, no.
Okay.
That would be on the already created file, of course. So not before. Yeah.
Yes.
There was some thinking. I don't know if that's going to come to fruition or not, but that's within this sort of framework of NASA Earth observation system, that there could be some recommendations and therefore some testing or validation tools that are going to be created out of there. And just last week I was at a meeting where there was a request to start creating these recommendations, how to generate cloud optimized HDF5 file. And maybe, maybe in that way we'll get to some kind of a tool in some context and for some communities. But yes, as far as the HDF group goes, there is no a linting tool that would maybe highlight some of these issues. Yes.
Actually, H5 start gives a lot of information that is useful to analyzing the files, because it will show that there are data sets with small chunks, how much metadata is there. So it's useful tool.
It is very useful tool, but it's for the keen eye that knows where to look. It doesn't slap you with a warning, sort of like, what are you doing, that kind of a proactive.
Can be modified, right? At least warnings can be added. Yeah. Thank you.
All right. If nothing, that's basically. Thanks for showing up. Thanks for questions and comments. And talk to you next month.
Okay. Thanks, Alexander.
Thanks, everyone. Bye.